Okay, our next topic is we want to find the arc length of a curve, of a parametric curve. So this is our next topic, arc length of a curve. Okay, again, if you remember from your previous knowledge from the calculus 2 or the integration, suppose that this is our function y equals to f of x, and this range or the domain is given to us. Mean f of x is defined on the interval a to b, and what is our main goal? Our goal is to find the length of this curve. We want to find the length of this curve from a to b, from this point to this point. So what is the formula? So if you recall from your previous knowledge, the formula is the following: integration from a to b under the root 1 plus dy by dx whole square, and then we integrate this with respect to x. But remember, here we are dealing with these parametric equations: x equals to f of t and y equals to g of t, and then we can substitute or we can modify this formula in the following way. For example, this formula can also be written in this form: dx by dx whole square plus dy whole square, okay, from a to b. But instead of this, we can substitute the derivatives of x and y. So when we substitute the derivatives of x and y, we get this formula, and this formula we get this formula, and this formula, it is written in the following way: integration from alpha to beta under the root dx by dt square plus dy by dt square, and we integrate this with respect to the time t. Here t varies from alpha to beta, So the problem is same. We are going to solve the same problem which we have discussed above, but before this we can do a very simple example. Okay, a very simple example. So suppose that we have the following. So this is a circle, okay, its center is 0 0, and what is the radius of this circle? We can suppose that the radius equals to 1, and for this circle, what are the parametric equations? The parametric equations of the circle are x equals to cosine of t, y equals to sine of t, and t varies from 0 to 2 pi. And what is the question? The question is, we want to find the arc length of this find the arc length of the circle. Find the arc length of this curve. Okay, so how can we find the arc length of this curve. So in order to find the arc length, first of all you need to find the dx by dt and then also dy by dt. So what is the derivative of cosine of t? The derivative of cosine t, it is minus sine of t, and the derivative of y, it is cosine of t. So we substitute, first of all we substitute these values. Okay, L equals to integration from 0 to 2 pi under the root. Here we will write minus sine of t whole square plus cosine of t whole square dt. Now this becomes following 0 to 2 pi under the root. Under the root we will get the following sine square t plus cosine square of t, and this is an identity. Okay, this is an identity, a trigonometric identity, and we know from our previous knowledge that sine square t plus cosine square t, this is equal to 1. So if we use this thing, what do we get here? It will become 0 to 2 pi under the root 1 dt, which is equal to 0 to 2 pi dt, and the answer to this, it is equal to 2 pi. So this is the arc length. Okay, this is the arc length, and we know that from our previous knowledge that the circumference of a circle, it is given by 2 pi r, and since the radius is equal to 1, so the length of the curve or the circle, it will be equal to 2 pi. So we get the same answer. Okay, the next question, let us do one more question. Okay, find the length of the arc of the cycloid. X equals to r theta minus sine theta, y equals to r 1 minus cosine of theta. This is the same curve which we have discussed here, this one. Okay, so let us do this thing. So this is the one arc, here it is 0 and this is 2 pi. And what is our main question? Our question is the following, that is, we want to find the arc length of this curve, mean we want to find this thing. Okay, we want to find the length of this curve. So how can we do this thing? So in order to do this thing, first of all we need to find dx by d theta, which we have already found above, which is 1 minus cosine of theta. And what is dy by d theta? It is equal to r. Now the derivative of 1, it is 0 minus, and the derivative of cosine, it is minus sine of theta, and when you simplify this thing you will get r sine of theta. Now the first thing you need to do is to simplify this thing, simplify this expression, because instead of writing this again and again under the integral sign, we will simplify this thing separately and then we will substitute this into our formula of integration. So this becomes the following. r square 1 minus cosine of theta whole square plus r square sine square of theta, and if you simplify this thing it will become r square 1 minus you can take this r square outside. Okay, I will do this in the next step. 1 minus 2 cosine of theta plus cosine square of theta plus r square sine square of theta. You can take r square outside as a common factor, and then it will become the following: 1 minus 2 cosine of theta plus cosine square theta plus sine square theta. Okay, so we get this thing, and then you can simplify this thing. So remember this thing from your previous knowledge, the square root of AB, it can be written in the following way: square root of A, square root of B. So outside here you can write this thing r square, and here 1 minus 2 cosine of theta. And here again we use that trigonometric identity, that is this thing cosine square theta plus sine square theta, it is equal to 1. Cosine square theta plus sine square theta, it is equal to 1. So this thing here, it is equal to 1 and it will give us 1. So now 1 plus 1, here this square cancels with the square root. So it will become 2 minus 2 cosine of theta. 2 minus 2 cosine of theta. Again we want to simplify this thing. Okay, again we will simplify this thing. So this thing becomes square root of 2, because we can take square root of 2 outside as a common factor, and inside we will get 1 minus cosine of theta. Okay, again we have to simplify this thing, because if you remember from your previous knowledge, we do not have any formula to integrate this thing. We don't have any formula to integrate this thing, but so in order to remove this square root, what we have to do, we have to use for example, the trigonometric identity which we have discussed above. I showed you here. These are the trigonometric identities. Sine square theta equals half 1 minus cosine of 2 theta. So let's write this identity here. Sine square theta, it is equal to half 1 minus cosine of 2 theta. Okay, now if we replace, what you have to do, you have to replace theta by 2 in this above equation. So if you do this thing, we get the following identity: sine square of theta by 2, it is equal to half 1 minus cosine of theta. And you can also bring this 2 to the other side, so it will become 2 sine square theta by 2, it is equal to 1 minus cosine of theta. So now you can substitute this value of 1 minus cosine of 2 theta here, and then what we are going to get, we will get the following. We will get the following, that is I will write this here: square root of 2 multiplied with r, and under the root we will get 2 sine square theta by 2. And now when you simplify this thing, we will get this thing. Remember, this square root of 2 multiplied with square root of 2, it becomes 2. So outside you will get 2r, and this square will cancel with the square root, and the answer will be sine theta by 2. Sine theta by 2. And remember, what is this thing? This is dx by d theta whole square plus dy by d theta whole square. Now we substitute this in our formula, and then we can find the length. So it is 0 to 2 pi. You can write this 2r outside the integral because this is a constant. Sine theta by 2 d theta. And what is the integration of sine? The integration of sine, it is minus cosine of theta. So here what do we get? So we get 2r minus cosine theta by 2 divided by 1 by 2. This is the formula, okay, from 0 to 2 pi. So remember this thing. How do we integrate this thing? I will write them here so that you can remember them. The integration of sine theta, it is equal to minus cosine of theta. It is equal to minus cosine of theta. Okay. And if you have any other function, a multiple of theta, for example, sine of a theta, what is the integration of this? It will be equal to minus cosine of a theta divided by a. Cosine of, what do we get here? Cosine of a theta divided by a. So this is, so by this formula we have obtained the integration of this, and now we can substitute. The limits of integration. It will become 4r with the minus sign, and now we can substitute the upper limit. When we substitute the upper limit, it will become 2 pi over theta, which is equal to pi minus, and when we substitute the lower limit, it will become 0, and then minus 4r. And remember, cosine of pi, it is equal to minus 1, and cosine of 0, it is 1, and 1 minus 1, it becomes minus 2. Minus 2 multiplied with minus 4, the answer, the final answer will be equal to 4r. So this is how you can